Welcome to Study Loop.
Let's evaluate the definite integral from -1 to 0. And our integrand, we see this fraction, polynomial divided by polynomial. Since the numerator has degree larger than or equal to the denominator, let's go ahead and do polynomial division. So x cubed divided by x squared is just x. Let's go ahead and multiply x by this polynomial on the left. And then subtract the whole thing. (3x squared minus 6x plus 1). And then 3x squared over x squared is just 3. So we have 3x squared minus 9x plus 6. Subtract. And we have 3x minus 5. So what this tells us is that we can take this integrand here and write this. So we're not looking at the integral, just a fraction on the inside. Our quotient was x plus 3. That's up here. Plus, then we have a fraction. On top goes the remainder, 3x minus 5. We got from down here our remainder. And then you take the original fraction, the original denominator, and that goes back down here. So we can integrate this thing instead. The first term, x plus 3, that's no fraction there, so no partial fraction decomposition necessary. But for the second term, we still have polynomial divided by a polynomial, so we should see if that denominator factors. And we see it does. We can write it as x minus 2, x minus 1. So this means that we should take 3x minus 5 This is what the book would call case 1 for partial fractions. You have distinct linear factors in the denominator, and they're not repeated. So we have a over x minus 2, and then b over x minus 1. And now we'll solve for a and b. So let's go ahead and multiply both sides by the denominator on the left. So go ahead and multiply this, both sides of this equation here. On the left, we just get 3x minus 5. On the right, we get a, x minus 1, and then b, x minus 2. And let's go ahead and rewrite that right-hand side. Let's factor out a x. We have a plus b. And then we have minus a minus 2b. So now we can look at the corresponding coefficients. On the left-hand side, the number in front of the x is a 3. On the right-hand side, it's a plus b. So that gives us one equation. A plus b equals 3. And then the constant term on the left is minus 5. And on the right-hand side, it's minus a minus 2b. And let's go to the next page. We have a plus b equals 3. And we also have a plus 2b equals 5. If we take that second equation from the previous page and multiply both sides by -1, we get a plus 2b equals 5. 2 by 2 system here for a and b to solve. So let's just go ahead and solve this for a and b. Many ways to do this. If we take the first equation, solve it for a, and then plug this a value into the second equation, we get 3 minus b, that's our a, plus 2b equals 5. And then just simplify this, and we have b equals 2. And then from this equation over here, Plugging this into a, we have a equals 3 minus 2, which is 1. So that resolves the question from earlier. So we had integral, actually let's not write the integral yet. The previous expression that we had after we did long division, we were at this step. Then we did partial fraction decomposition for this fraction. So x plus 3 stays the same. And then we had a, which was 1. So it's a 1 over x minus 2 plus b, which was 2 over x minus 1. So now this is the term that will integrate. I'm running out of room here. Let me go to the next page. -1, 0, x plus 3, 1 over x minus 2, 2 over x minus 1. Now, if these last two terms are bothering you because of the subtraction, you can go ahead and do a u substitution for each of these. Here you would do u equals x minus 1. When we integrate, we should get x squared over 2. That's the power rule. 3 times x. That's just a constant 3, so 3x. Natural log absolute value x minus 2 plus 2 natural log absolute value x minus 1. And then our endpoints were minus 1 and 0. Now we just go ahead and plug in the endpoints. If we plug in 0, the first term is 0, the second term is 0, and then we get natural log absolute value of -2, so that's just ln 2. And when we plug in 0 into the last term, we get natural log of 1, which is 0. So we just have ln of 2 for 0, and then we plug in -1. So -1 squared is just 1/2. 3 times minus 1, so let's do minus 3 plus, then we have natural log, -1 minus 2 in the absolute value, so that becomes a 3, plus 2 times natural log, similarly this becomes 2. So 2 times natural log of 2, and the last step here is just to cancel out and simplify as much as we can. We have 1 natural log of 2, and then we're subtracting 2 of those, so that leaves us with negative natural log 2. And then here we have 1/2 minus 3, that's -5/2. We have another negative over here, so that becomes a plus 5/2. And then we also have this negative ln 3 here. So it's sloppy, let me erase this, ln 3. And we could either stop right there, or if you want to simplify this a little more, you could combine those logs. You have a minus, and then we have ln 2 plus ln 3. So that's using your log properties. You could write this as minus ln of 2 times 3, which is ln 6. So here either answer should be fine. This or this, and that's our final answer.